Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss quadrilaterals. In this chapter, today we are going to discuss the concepts of exercise 8.1 and theorem 8.1. Are you ready to listen the class, my dear children? Right. Now, first point. This is the first point. First of all, let us discuss the definition of a quadrilateral. What is meant by a quadrilateral? A figure formed by joining 4 points in an order is called a quadrilateral. A quadrilateral has 4 sides and 4 angles and 4 vertices. So this is about a quadrilateral. You have already studied about quadrilaterals in your earlier class. In 8th class, understanding the quadrilaterals chapter is there. In that chapter, you have already learned what is meant by a quadrilateral. Just for strengthening our previous knowledge, again we are repeating that same point here. Quadrilateral means a figure formed by joining 4 points in an order is called a quadrilateral, and a quadrilateral has 4 sides, 4 angles and 4 vertices. Okay, my dear children, right. To understand this concept, to understand a quadrilateral, let us take an example. Okay, my dear children, right. See here, observe this figure 8.2. Figure 8.2. Here two figures are given. These two are quadrilaterals. Okay, my children. Right. Now, in quadrilateral ABCD, AB, BC, CD and DA are the 4 sides. A, B, C and D are the 4 vertices and angle A. And this angle A is also written as angle DAB or angle BAD. Similarly, angle B, this angle can be written as angle ABC or angle CBA, and angle C or angle BCD or angle DCB, and angle D, this also can be written as angle ADC or angle CDA, or 4 angles formed at the vertices. Okay, my children. Here, this is the name of the quadrilateral. ABCD is the name of the quadrilateral. In this quadrilateral, this is side AB, BC, CD, and DA. These are called these line segments. These are all line segments only. But with respect to quadrilateral, these line segments are called sides. These 4 line segments are called sides of these quadrilateral, and these points A, B, C, D, these 4 points are called vertices. Actually, these are points only. A is a one point, B is another point, C is another point, D is another point. These 4 points are said to be vertices with respect to this quadrilateral, and angle A, angle B, angle C, and angle D. These are 4 angles of this quadrilateral. Okay, my children. Right. Now come to the next point. Now join the opposite vertices A to C and B to D. See the figure 8.2 second. So observe this figure, my dear children. 8.2 second figure. Here we have joined the opposite vertices A and C and the opposite vertices B to D. Then we get AC and BD line segments. These are also line segments. but these two line segments are said to be diagonals of this quadrilateral ABCD. Understood this point, my dear children? Right. In this chapter, we will study more about different types of quadrilaterals. Different types of quadrilaterals. Their properties, and especially those of parallelogram. So, in this chapter, we focus on studying different types of quadrilaterals and their properties, and especially we focus on parallelograms. Parallelogram is also a one type of quadrilateral. Okay, my children? Right. Now come to the second point in this chapter. Now let us discuss the second point, that is angle sum property of a quadrilateral. Angle sum property of a quadrilateral. In the triangles chapter, you have studied angle sum property of a triangle. Similarly, here we discuss angle sum property of a quadrilateral. The sum of the angles of a quadrilateral is 360 degrees. The sum of all the angles of a quadrilateral is 360 degrees. Now let us take an example. ABCD is a quadrilateral. Let ABCD be a quadrilateral. See the adjacent figure. Observe the adjacent figure. Here ABCD is a quadrilateral. Okay. Okay, my children? Right. Then angle A plus angle B plus angle C plus angle D is equal to 360 degrees. In this quadrilateral, what are the angles? Angle A, angle B, angle C, angle D. These are four angles of this quadrilateral. Therefore, angle A plus angle B plus angle C plus angle D is equal to 360 degrees by this angle sum property of a quadrilateral. We can say that angle A plus angle B plus angle C plus angle D is equal to 360 degrees. Remember this angle sum property of a quadrilateral. Okay, my children? Right. Now come to the third point. Types of quadrilaterals. Here we are going to discuss types of quadrilaterals. Previously I told you there is a lot of difference between name of a quadrilateral and types of quadrilaterals. Here the name of this quadrilateral is ABCD. This is name of the quadrilateral. ABCD is a name of the quadrilateral. Now we are going to discuss types of quadrilaterals. We have already studied the types of quadrilaterals in earlier class, 8th class itself. In the understanding the quadrilaterals chapter, we have already studied. We recall that previous knowledge. Okay, my children. Right. How do you classify the quadrilaterals? Yes. See this point, my dear children. Based on the nature of the sides or angles of a quadrilateral, it gets special names. So we classify the quadrilaterals based on the nature of sides or angles of the quadrilateral. Okay, my children. Right. This is a first type of quadrilateral, trapezium. What is meant to be a trapezium? See this figure, my children. This is a trapezium. It is also a quadrilateral. This is one of the types of quadrilaterals. ABCD is a trapezium. Do you remember the definition of a trapezium, my children? Right. See this definition of a trapezium. one pair of opposite sides of a quadrilateral ABCD in the figure 8.51, namely AB and CD, are parallel. You know that it is called a trapezium. It is called a trapezium. So in any quadrilateral, if one pair of opposite sides are parallel, then the quadrilateral is called a trapezium. Okay, my children, right. Now come to the different types of quadrilaterals and their properties. Parallelogram. A quadrilateral with each pair of opposite sides parallel. In any quadrilateral, opposite sides, each pair of opposite sides, there are two pairs of opposite sides, AB and its opposite side is CD. BC is one side, its opposite side is AD. So AB is parallel to CD and BC is parallel to AD. Then this quadrilateral is called a parallelogram. Then what are the properties of a parallelogram? Opposite sides are equal. In a parallelogram, opposite sides are equal. Similarly, opposite angles are equal. What are opposite sides in this parallelogram ABCD? Yes, AB and CD are opposite sides. So AB is equal to CD. Similarly, BC, what is the opposite side of this BC? Yes, AD. So BC is equal to AD. Understood this point, my children? Similarly, opposite angles are equal. What are opposite angles in this parallelogram ABCD? Angle A, its opposite angle is angle C. Opposite angle of A is angle C. Similarly, the opposite angle of B is angle D. So angle A is equal to angle C and angle B is equal to angle D. And the third property, diagonals bisect each other. What are the diagonals of this parallelogram? AC is one diagonal and BD is another diagonal. They bisect each other. Bisect each other means, suppose AC length is 10 centimeters. AC length is 10 centimeters. They have intersected at a point. So here AO is 5 centimeters and OC is 5 centimeters. AO and OC are equal in length. Similarly, if BD is 30 centimeters, then BO and OD, these two line segments are also of equal length. They are also equal in length. Understood this point, my children? Bisect means equally they are intersecting in length. Equally, their point divides this line segment into two equal line segments. So indirectly we can say that O is the midpoint of AC and O is the midpoint of BD also. Understood this point, my children? Right. Next type of quadrilateral is rhombus. What is meant by a rhombus? A parallelogram with the sides of equal length. In a parallelogram, in a quadrilateral or in a parallelogram, all sides are equal. Then the quadrilateral or then the parallelogram is called a rhombus. Then come to the properties of a rhombus. All properties of a parallelogram. All properties of parallelogram also properties of rhombus. Next point, diagonals are perpendicular to each other. Here, what are the diagonals here? Yes, PQ is one. PR is one diagonal, PR is one diagonal and QS is another diagonal. So these two diagonals intersect perpendicularly, means here the angle here is 90 degrees. Here 90 degrees. they cut each other at the right angle. Here if you measure the angle between the diagonal PR and SQ, here 90 degrees, we get 90 degrees. That is the meaning of diagonals are perpendicular to each other. They intersect at point O, suppose. Then at point O, if we measure the angle between PR and SQ, then we find that they form a right angle at this point O. Okay, my children, right. Now next type of quadrilaterals. See that you have already studied this type of quadrilaterals in your earlier class. Rectangle. It is also a parallelogram with a right angle. So in a parallelogram, if one angle is a right angle, then the parallelogram automatically becomes a rectangle. Okay, my dear children, right. Then what are the properties of a rectangle? All the properties of a parallelogram, because rectangle is also a one kind of a parallelogram. Next, each of the angles is right angle. Previously we have discussed each angle in the rectangle is 90 degrees, right angle. Next, third point, diagonals are equal. What are diagonals here for this rectangle? Yes, KM, KM and LN. KM and LN. These two are diagonals. They are equal in length. Understood this point, my children? Right. And moreover, they bisect each other. If they intersect at a point, then we can say that the point O is midpoint of KM and it is midpoint of LN also. Understood this point, my children? Right. Next, come to the next type of quadrilateral square. A rectangle with sides of equal length. So, in a rectangle, if all sides are equal, then the rectangle becomes a square. Okay, my dear children. Now come to the properties of a square. All properties of a parallelogram, rhombus and rectangle. What are the properties satisfied by a parallelogram, a rhombus and a rectangle? All these properties are satisfied by a square. Okay, my children. And now come to the, it means, let us discuss here. Square, properties of a square. All sides are equal. Next, each angle, each angle in this square is 90 degrees. Each angle is 90 degrees. Each angle of a square is 90 degrees. Next, now come to the diagonals property. What is a diagonal here? PR. PR is one diagonal and SQ is another diagonal. These two diagonals are equal and they cut each other perpendicularly. They cut each other perpendicularly. If they intersect at O, then O is the midpoint of PR. O is the midpoint of the diagonal PR and O is the midpoint of the diagonal SQ. And moreover, if you measure an angle between PQ and SR at this point O, we get a right angle. So diagonals of a square are equal and they bisect each other at a right angle. Understood this point, my children? Right. Next is a kite. A quadrilateral with exactly two pairs of equal consecutive sides. If you observe this quadrilateral, in this quadrilateral ABCD, AB and AD, these two sides are consecutive sides. A pair of one consecutive sides. This is BC and CD. This is one pair of consecutive sides. Here AB length and AD length are equal. Similarly, BC length and CD length are equal. Then this quadrilateral is called a kite. Now come to the properties of a kite. Diagonals are perpendicular to one another. If you draw diagonals, what are the diagonals of this kite? Can you tell me? Yes, AC, AC and BD. These are diagonals of this kite. If they intersect at a point O, if the diagonals intersect at a point O, then if you measure the angle between the diagonals AC and BD, we get a right angle. If you measure the angle between the diagonals AC and BD at this point O, because they are intersecting at a point O, then the angle between the diagonals is 90 degrees. That is the meaning of the first property. The diagonals are perpendicular to one another. Now come to the second property. One of the diagonals bisect the other. In these two diagonals, if you observe here, the diagonal AC bisecting the diagonal BD means here O is the midpoint of BD. Here these two diagonals are intersecting at point O. And here O is a midpoint of BD, means BO is equal to OD. That is the meaning of the second property. One diagonals of the kite bisect the other. Let's come to the third property. In the figure, measure of angle B is equal to measure of angle D. Here measure of angle B is equal to measure of angle D. These two angles are equal, but and measure of angle A is not equal to measure of angle C. These are the properties of a kite. Okay, my children, right. Now come to the next point, fourth point of this exercise 8.1. What is the fourth point here? See here, elements of a parallelogram. What are called elements of a parallelogram? See this point, my dear children, carefully. There are four sides. There are four sides and four angles in a parallelogram. You know that there are four sides and four angles in a parallelogram. Some of these are equal. Some of these are equal. They are some terms associated with these elements. So these are called elements, sides, angles. Okay, these are called elements of this parallelogram, and some terms are associated with these elements. Let us see what are the terms related to these elements that you need to remember. These terminology. See this figure 3.18, my dear children. This is a parallelogram ABCD. What is the name of this parallelogram? Yes, ABCD. Observe this parallelogram carefully, my dear children. Given a parallelogram ABCD, observe the figure 3.8. AB and CD or DC. AB and DC are opposite sides. They are opposite sides. AD and BC form another pair of opposite sides. In this figure, AB and DC are one pair of opposite sides, and BC and AD form another pair of opposite sides. Similarly, angle A and angle C are pair of opposite angles. Previously I told you angle A and angle C is one pair of opposite angles. Similarly, angle B and angle D are form a pair of another opposite sides, a pair of opposite angles. Now AB and BC are adjacent sides. AB and BC are adjacent sides. This means one of the sides starts where the other ends. See here, my dear children, AB side ends at B. So this side BC is starting with point B. So these two sides are said to be adjacent sides. Or BC and CD adjacent sides too? Yes, BC and CD also another pair of adjacent sides. Like this, we can find a pair of adjacent sides. CD, DA. This is one pair of adjacent sides. DA, AB is another pair of adjacent sides. Like this, we can find four pairs of adjacent sides. Okay, my children. Right. Angle A and angle B are adjacent angles. Here, angle A and angle B are said to be adjacent angles. Similarly, angle B and angle C are said to be adjacent angles. Similarly, angle C and angle D is a pair of adjacent angles. Similarly, angle D and angle A is a pair of adjacent angles. Likewise, we can find four pairs of adjacent angles. Understood this point, my children? Right. Now come to the next point. Fifth point. Properties of a parallelogram. You have already learned properties of parallelogram. Let us recall that properties of parallelogram. Okay, my children. Right. The properties of parallelogram are given as theorem statements of some theorems. See here, theorem 8.1. Theorem 8.1. A diagonal of a parallelogram divides it into two congruent triangles. This is a properties of a parallelogram. One of the properties of a parallelogram. A diagonal of a parallelogram divides the parallelogram into two congruent triangles. Okay, my children. Right. Now come to the second property. This is also given as a statement of another theorem. Theorem 8.2. This is a theorem 8.2 statement. In a parallelogram, opposite sides are equal. You know this property. Opposite sides of a parallelogram are equal. Yes or no, my children? Right. Now come to the third property. It is also given as statement of theorem 8.3. See this property. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. In any quadrilateral, each pair of opposite sides, if they are equal, then the quadrilateral is called a parallelogram. Okay, my children. Right. Now come to the next property of a parallelogram. This is given as statement of the theorem 8.4. In a parallelogram, opposite angles are equal. In a parallelogram, not only opposite sides are equal, opposite angles are also equal. This is also one of the properties of a parallelogram. Okay, my children, remember all these properties well. Now come to the next property of a parallelogram. It is also given as statement of the theorem 8.5. If in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. Okay, my children, in a quadrilateral, in any quadrilateral, if each pair of opposite angles, if they are equal, then the quadrilateral is called a parallelogram. Okay, my children, right. Now come to the next property of a parallelogram. This property is given as statement of theorem 8.6. The diagonals of a parallelogram, The diagonals of a parallelogram bisect each other. Previously we have discussed this point also. The diagonals of a parallelogram bisect each other. Okay, my children. Right. Now come to the next property of a parallelogram. This is given as a statement of the theorem 8.7. If the diagonals of a quadrilateral bisect each other, the diagonals of a quadrilateral bisect each other, then the quadrilateral is called a parallelogram. Understood these properties of a parallelogram, my children? Out of all these 7 properties, we give more importance to the first, the theorem 8.1. A diagonal of a parallelogram divides it into 2 congruent triangles. We prove this theorem also. Okay, my dear children, there is no need of proving these remaining theorems 8.2, 8.3, 8.4, 8.5, 8.6 and 8.7. If you are interested to prove these theorems, you can go through the textbook. In the examination point of view, they will not ask the proof of these theorems. Okay, my children. Right. As I said, the proof of the theorem 8.1 is important. That is why we are discussing the proof of this theorem 8.1 now. What is the statement of theorem 8.1? A diagonal of a parallelogram divides it into 2 congruent triangles. This is the statement of the theorem 8.1. We are going to prove this theorem. Okay, my children. Right. Now observe this diagram. Observe this figure 8.8. It is a parallelogram. ABCD is a parallelogram. In this parallelogram, what do you know here? Opposite sides are equal. That is, AB is equal to DC and BC is equal to AD. Yes or no, my children? Right. Now we are going to prove this theorem. Now let us take a quadrilateral ABCD. Let us take a parallelogram ABCD. Here we have taken a parallelogram ABCD, in which AC is one diagonal. See this figure 8.8. See the figure 8.8. In this parallelogram ABCD, AC is one diagonal. Now we are going to prove that this diagonal AC divides this parallelogram into 2 congruent triangles. How many triangles you are finding in this figure? Yes, triangle ABC and triangle ADC. Yes or no, my children? These two are 2 triangles. The diagonal dividing this parallelogram into 2 triangles. Observe that the diagonal AC divides parallelogram ABCD. The diagonal AC is dividing the parallelogram ABCD into 2 triangles, namely triangle ABC and triangle CDA. Yes or no, my children? Triangle ABC and triangle CDA. Now we are going to prove that these 2 triangles are congruent. Understood this point, my children? Right. We need to prove that these triangles are congruent. These triangles are congruent. Okay, my children? Right. Now let us compare the parts of these 2 triangles. In triangle ABC and triangle CDA, note that BC is parallel to AD. Here BC is parallel to AD and AC is transversal. Yes or no, my children? Right. So angle BCA angle BCA is equal to angle DAC, because these two angles are a pair of alternate angles. Angle BCA and angle DAC. These two, this angle and this angle is a pair of alternate angles. They are equal because these two lines are parallel. Okay, my children. Also, AB is parallel to DC. Also, here AB is parallel to DC, and AC is a transversal. Here also AC is a transversal. Then, which angles are equal? Yes. So, angle BAC equal to angle DCA. This pair of angles also a pair of alternate angles. So here these two angles are also equal because their two lines are parallel. AB and CD are parallel lines. We have used that alternate angles property. Okay, my children. Right. Now AC is equal to AC. It is a common side in these two triangles. AC is equal to CA. So triangle ABC is congruent to triangle CDA. By ASA congruency rule, we can say that triangle ABC is congruent to triangle CDA. Understood this point, my children? You should be very strong in triangles chapter also. Without knowing the congruency properties, without knowing the alternate interior angles properties, lines and angles and the triangles, in those two chapters we have learnt all these points. We have to use these points in proving these statements. Okay, my children? Right. Or diagonal AC divides parallelogram ABCD. Here diagonal AC divides the parallelogram ABCD into two congruent triangles. Understood this point, my children? Right. What are the two triangles, congruent triangles? ABC and CDA. Okay, my children, understood this theorem 8.1. This is a very important theorem in the examination point of view. It is a very important theorem. So please learn this theorem well. Okay, my children. Right.